Hello, this is a tutorial for programming a TI-84 calculator. This isn't meant to be the best tutorial or the most in-depth tutorial. There are people who have already covered that. Rather, this is meant to be an easy to follow and extremely introductory tutorial for programming a TI-84. Now let's get started. To program, you got to click on the program key, obviously, and you have executable, edit, and new. We have no programs, so let's create a new one. For this fun tip for naming, you can use second and then alpha lock, and that gets you into all these alphas, which are, the majority are letters. And so what I'm going to do is I'm going to take, I'm going to do an example. So EX, there's a max of 8 characters, so example is just going to fit in there. Example. And we got one letter left. You see if I put in another A, it says I can't put in any more characters. So I'm going to delete that by pressing back and delete. Now we have this. All right. Now with program example, what do we got to do? Well, programs are like sandwiches with 3 layers. Not all of them. You have a prompt because it needs to know what to do first, so it needs to have values in certain variables. So what we're going to do is we're going to take A, comma, B. This gives us 2 variables. Now I'm going to be programming the Pythagorean theorem, and I'm going to do a simple sort of cutthroat dry version of the Pythagorean theorem. It's going to be easy to follow and easy to understand, but not optimized. So with that, we have prompt A and B. And we're going to take A and B, and we're going to go down into our next line and compute or do something with them. And so I'm going to take A squared, like in the Pythagorean theorem, plus B squared, and then instead of just saying it's equal to C squared, we got to store it to C. What this does is it sets the value of the variable C in your calculator to A squared plus B squared. Now we're going to go down into our next line and say the square root of C, and then instead of saying it's equal to another variable, which we can then display, we're going to store it to another variable. And so that's going to be D. And so in our final line, we have a display, and then we're going to set up the variable D. It doesn't matter that A equals B, A plus B equals C in the Pythagorean theorem, because we're not going to be seeing D. We're going to see the value that D represents. So to exit a program, it's already saved, so we can just do quit. And then we go into program. We have example right here. Go in, and then we press enter. This reads the first line. It's asking us what A is. That's why it says A question mark. And so I'm going to set A is equal to 5. So I'm going to put in 5, put in the next line, put in another 5 for B, next line. It gives us this value. And so basically what it just did is it said A squared is 25, B squared is 25, add them together, you get 50. Now we're going to store that to C. C is now equal to 50. And then the square root of 50 is going to be stored to D. And it just displayed D to us right there. Now, this isn't optimized. So let's go back in. Let's go to Program, and let's do Edit. Edit's useful because you don't need to go into New and make an entirely new program. You can just edit the ones you have there. And so, what is necessary here? We have A plus B squared, A squared plus B squared, and we're storing that to C. And then C, the square root of it, is being stored to D. We don't need to have a new variable. We don't need to have C as an intermediary. We can put that all in one thing. So we're going to clear these rows, in fact all of them, because I want to get rid of D as a variable. And so I'm going to say the square root, or I'm going to ask for the square root of a squared plus b squared. Close that. And so what it does is it does the previous calculation, and then it finds the square root of it automatically without needing c. And so we're going to use c in a different form. We're going to store that to c, and now c is going to take the place of what d previously was. We're going to display c as what we did before. And so if all goes correctly, we should have the same answer that we did previously. So we're going to execute example, and we now have we see our previous answer was 7.07106, yada yada. And so we have A5, B5, and we get the same answer, but we removed a variable in a line of code. So not only does it take up less space, but it works faster. Now that we've achieved that, we have a working program. We can repeat that program as many times as we need, and it'll always give us an accurate answer. Thanks for watching. This has been a tutorial for programming a TI-84 calculator.